So welcome back, PreCalc. We are finishing up the 2.2 Day 2 notes, and I had last left off with part D of number 3. And so what we're doing is we're finding the limit as x approaches 0 from the right. All right, so as we approach 0 from the right side, the right branch is going to be this guy here. So essentially we are doing the limit as x approaches 0 of x plus 4 all over x plus 5. Now, we're approaching 0. This time 0 is not a vertical asymptote like it was in this one. So it's not going to be approaching infinity or negative infinity. Okay, it's only when we're approaching a vertical asymptote that the limit will approach either infinity or negative infinity. This one, 0, you can just plug it in. All right, if you plug it in, you're going to get 0 plus 4 on the top, 4, and 0 plus 5 on the bottom. So it's going to approach 4/5. All right, and that's it. So that's kind of how that one works. Let's go to the back. All right, number 4 is kind of a doozy. You're going to see one similar to this in the homework. We've got the limit as x approaches 0 of sine of 4x over x. Notice this looks very similar to when we've been doing before. We've been doing a lot of sine of x over x. This is sine of 4x over x. So what we want to do is try and make this look more like this. So this one's kind of a weird one. What we're going to do is we're going to let t equal 4x. Why we chose the letter t, I'm not really sure. I think the book uses that. So that's what we're going to do. We're going to let t equal 4x. If you were to take this equation and solve for x, so you divide by 4, we know that x would equal t divided by 4. All right, we're going to do some substitutions. So we're going to do the limit as x approaches 0 of sine of, instead of 4x, we're going to put t all over, instead of x, we're going to put t over 4. All right, so we're doing the sine of t divided by t over 4. Remember that when you divide by a fraction, it's the same thing as multiplying by the reciprocal. So we're really doing sine of t times 4 over t. So let me split this up. Okay, we're going to do the limit as x approaches 0 of sine of t times 4 over t. All right, and I am going to split this up, but I'm going to split it up so that the t is under the sine of t, so that it looks just like this guy, except t's instead of x's. So we're going to do the limit as x approaches 0 of sine of t all over t times the limit as x approaches 0 of just 4. Okay, because if you multiply those together, you do get the same thing. And when we do this, we're going to find the limit of each piece. All right. Oh, I wrote a 4 here. I apologize. This should be a t. Sine of t all over t. I'm putting this t underneath the other guy there. All right, times the limit as x approaches 0 of 4. All right, when you do the limit as x approaches 0 of sine of t over t, or sine of x over x, we know that it approaches 1. And then the limit as x approaches 0 of 4, it's just going to be 4. So 1 times 4, you're going to get 4 for your answer. So that one's a little bit weird because you have some substitutions going on, but hopefully once you do the substitutions, you can see why it's equal to 4. Number 5 and 6 are going to deal with something called a power function and behavior model. All right, a power function and behavior model. This is going to be pretty simple to do. What you're going to do is we're going to be finding the power function for f of x equals negative 4x cubed plus x squared minus 2x minus 1. When you're dealing with a power function, if it's just a single function like this, there's no denominator or anything, you're just going to take the very first term. Once it's in descending order, take the very first term. So it's going to end up being y equals negative 4x cubed. All this means is that this function is going to generally follow the same path as y equals negative 4x cubed. It's got a few little adjustments because of everything being added or subtracted to it at the end, but in general, it's going to follow this function, y equals negative 4x cubed. As far as a horizontal asymptote goes, if you look at negative 4x cubed, all right, there is nothing in the denominator. There isn't going to be a horizontal asymptote. All right, you could graph it if you needed to, but there is no horizontal asymptote for this particular function. All right. When the degree in the numerator is greater than the degree in the denominator, there's no horizontal asymptote. Okay, so then for this next one, all right, what we're going to do is same thing. We're going to find the power function. Now this time we have a fraction. So the power function is going to be, once it's in descending order, the very, very first term on the top over the very, very first term on the bottom. So we're talking about x squared all over negative x to the fourth. All right, when you reduce that, you're going to get y equals negative 1 all over x squared. That's going to be our power function. This function in general is going to follow fairly similar path to y equals negative 1x squared. When you look at negative 1x squared, 1 over x squared, I apologize, 1 over x squared, the horizontal asymptote, there will be a horizontal asymptote. You could graph this to see what it is. All right, the other possibility is the degree on the denominator is greater than the numerator, so the horizontal asymptote is going to be 0. All right, so y is going to equal 0. That's our horizontal asymptote. And that's it. That's how we do our power function and behavior models and our horizontal asymptotes. That's it. Thanks.